All right, 1-2. How do you classify the data? These first two, not too bad, because if you just kind of look at the vocabulary there, there's qualitative data versus quantitative data. Like when you hear the word qualitative, what kind of root word comes to mind? A quality, right? Some kind of characteristic that maybe it has, or a quality that it has. And that's exactly what we're looking at. It consists of, that's data. Remember what data is from the other day. That's some kind of thing that we've looked at. And it consists of attributes, labels, or non-numeric entries. Now, right now, you might not be able to come up with an example of what qualitative data is because you've never probably really thought of it that much, but we'll try and clear that up in a little bit. How about quantitative? What's kind of the root there? Quantity, exactly. And quantity means amount or how many, or yeah, exactly. Okay, so those two, not too bad. They kind of tell you what it means. Consist of numerical measurements or counts. More than likely, you're more in a math class, you're more used to the quantitative data. All right, you add things up, you count them, you measure them, right? You get some kind of answer for that. For qualitative, you're probably not as accustomed to. I realize I must have changed these notes at some point because I kind of asked the same question twice. So we'll kind of forget the question that's up here at the top here. But it does say that it's giving you the populations of several U.S. cities are shown right here. We won't worry about the which data are qualitative and quantitative because I think I asked that later. So we'll just answer that down here. All right, so there we've got what? Baltimore, Boston, Dallas, Vegas, Lincoln, and Seattle. Okay. And these are actually fairly accurate numbers as of maybe like 5-6 years ago, I believe. Maybe a little bit longer. Okay. It's funny that Vegas' population is only 300,000, but then most of the people that are there don't live there. All right. And Lincoln, obviously, a little bit smaller. Dallas, a little bit larger. So what are the contents of each data set? Well, what are some of the things that we have? We definitely have population, right? That's data. You agree with that? Population's definitely in here. I'd say there is one other piece of data. Yeah. The city. Yeah, exactly. Again, when you're in math, you always think of data as being some kind of number. Well, it doesn't have to be. Data is kind of like that information, I think, is one of the words a lot of you used on that first day survey. Okay. So those would be your two data sets. Okay. So let's decide whether the data consists of numerical or non-numerical entries. So how about for the population? Are those numerical or non-numerical? Numerical. Okay. And the city is non-numerical. Is that spelled right? I guess it is. Non-numerical. So hopefully if you look at those two answers that we just get, it should help you answer this next one to specify which ones are qualitative and which ones are quantitative. Okay, so in this one, qualitative is going to be which one? Qualitative is the city for qualitative, right? Is city. Now I'm cheating, sorry. And then quantitative, or a quantity, is the population. No, I'm really cheating. So that's really not the part of this particular notes that I'm worried about. It's kind of what comes next that I'm a little bit concerned about. So hopefully I can teach it well enough so that it's easily understood. There are actually 4 main levels of measurement that you can have when collecting any type of data. All right. And what we're going to do is we're going to start off with the most basic, and we're going to work our way up to the most complex. That most complex is what you're used to. Right? But there is some kind of underlying types of measurement that can be made, and so those are probably going to be the ones that we're going to struggle with a little bit, okay? Because you just haven't thought of it before. Okay? So the first one of the most basic level is the nominal level, and that makes sense. Nominal, when you think of that word, you think of kind of basic, right? And it's kind of just the basic level of, and again, you can paraphrase this if you want, but there are definitely some keywords in here. This data is going to be qualitative only. So it's only going to have a quality, not necessarily a quantity. I think probably one of the key words in here, for me at least, is that this data is going to be categorized in some way. Or they're all going to fall into the same category. Maybe I should put it that way. You're not really going to calculate anything. And I'll give you time to write whatever you want there, and I'll try and give you some examples so that hopefully will help. I kind of looked at, there would be no natural order to the data, you know. Exactly, yeah, no natural order like 1, 2, 3, 4 or something like that. You wouldn't know. And the example I used last year that I think may have possibly confused some people, and I think that's because I presented it very poorly, and so that's why I want to do it better, is let's say I gave you a bag of M&Ms. Of course, everybody would be okay with that, right? And I asked you to count them. Would you all start by counting the same color? Or would maybe one of you start counting brown, and one of you would start by counting orange? And when you organized it in a table, would you all put the first color and first color is brown, or the second color is orange? No, you wouldn't. Now the actual counts, like if you had 10 orange or 12 brown, that's numerical, correct? But you look at the labels, you'd say you have what are they? Orange, brown, what, blue, red, yellow, did we get them all? Green, I think maybe, right? So if I look at those labels, are they categorized in some way? They are by color, right? They're categorized by color. Are you really going to do any calculation between orange and blue? Can I like subtract and find some answer there? No, not between orange and blue, right? How about between red and yellow? Am I going to be able to do anything there? Okay, is there any natural order that you would necessarily want to put in? No, probably more than likely you'd just start counting whatever the first one you saw, right? So is there any way that we would sit there and always do it all the same way? No. Okay, so putting them in those categories like that, that's nominal. Putting them in the categories of orange, and because there's no natural order to it, correct? Now what if we start talking about dates? We're probably going to put those in a natural order, probably chronological. You see the difference? Okay. Or if we have talk about the conference that you're in for sports, are we probably going to put those teams in some kind of order? Yeah, and everybody's going to kind of agree on that. But how about the M&M example? Is there any natural order that everybody's going to follow on that when they start adding them up? No, somebody might do blue, somebody might do red. Who knows, right? Okay, so does that make sense, the difference that I made there for you? Okay, because that's big. So in other words, they were put in a category, but really you see on mine with the orange and the red, is there any mathematical computation you're going to do there? No. How about from 1 year to the next, like 1993 to 1994? Well, that's a 1 year difference, right? Okay, that's something you can actually calculate. Okay, so that wouldn't be nominal, where that M&M one it is. Okay. Another one that you're probably going to see on one of your assignments is, what if in this class I just wanted to count male versus female? If I were to graph that, is there any rule that says males would have to be graphed first or females would have to be graphed first? Or am I going to subtract female and male, the actual words? Am I going to subtract those actual words and get some answer out of that? No. How about the actual counts? When I actually count you, could I subtract that? Yeah, that's an actual number, right? But we're looking at the labels here. When you put them in those categories, can you do anything with that category? Not really if we do male, female, right? There's not much I can do with that category, actually subtraction-wise, okay? So how about ordinal? That's the one word that I told you I know you've heard in elementary, but it's been a long time. That and cardinal are probably numbers that you've haven't heard for a very long time. What do you think of ordinal? What word comes to mind? Order. Okay. So now you start with nominal. Okay, that's basic, right? So now we're going to add a characteristic. So we can still categorize them, but now once we categorize them, what do you think is going to be different here? I can put them in some kind of order. All right. So this can actually be qualitative and quantitative. It can be both. Actually, they are. But now I can arrange them in some order. And I think it's right. You have to kind of look at the labels here is kind of what we're looking at. All right. And the difference between the data entries is not meaningful, meaning that calculation that you could do between those labels really doesn't tell you anything. That's what I mean by not meaningful. That calculation's like, okay. So I think a great example, I've already given you a great example of interval. Actually, a couple of good ones. Would be like in your conference. You're going to put them in some kind of order when you list the teams, correct? We're going to go first, second, third. Those are our categories, right? First, second, third, fourth. Am I really going to say take second versus first? Oh, the difference there is 1. Does that really mean anything in that calculation? No. Does that tell me how close those two teams are in standings? Like, could they be 2 games back or 5 games back, right? But just taking the second minus the first, does that tell me how close they really are? It's a 1, right? How about 5 minus 1? If you're 5th place minus, you're 4 away, right? But does that tell me how close that is? Because technically, couldn't 5th place could be really close, or it could be way not even in the game, right? So do you see what I'm talking about? I'm talking about the labels here, the categories you put them in. When you actually subtract those, is there any meaningful difference there in this case? No, not really. Okay. And a lot of times people would possibly put time in here, but you got to be careful with time, and we'll talk about that in a little bit. Yeah, we know 1993 to 1994, that's 1 year, but does that necessarily tell me anything about the data that happened in 1993 and 1994? Maybe not. Okay. Again, looking at labels, this is key, because what do you all want to look at right now? You want to look at the counts, don't you? Because what have you always done in math? You've counted things. You find out how many are there. And that's not what we're trying to do here. So how are we doing so far in these two? Nominal and ordinal. Do you know what I mean by no meaningful calculation? Does that make sense? Okay, so let's try these. Here's how I do it. I always say, is it nominal first? If it's nominal, then I'll go see, is it also ordinal, right? Because it kind of works its way up. It has more characteristics. So what do you think about this one here? The final standings for the Northeast Division for the National Hockey League. Is that going to be categorized in some way? Yeah. Okay. They're going to put them because they're all in that division, right? That's the category we're looking at. And they're hockey teams. Okay. They didn't throw in like a soccer team or something here. All right. They're all in that same category. They're all there. So it's nominal for sure. Now we have to decide, is it ordinal? In other words, can I arrange them in some type of natural order? Yes, we would probably go first, second, third, fourth. Okay. And then we have to, again, think, would that mean the difference between first and second, is that a meaningful calculation? Okay, if you're in first or second, it might mean something to you, right? But as far as actually the math behind that, that's just not really, right? It doesn't tell you how close first and second is, right? Because we don't know how many games back they are. So what answer would you put here? Is this nominal or ordinal? Ordinal, most definitely. Well, technically ordinal is nominal plus some more characteristics? Okay, I want like the best answer. Yeah, good question. Because really, you could put both there, right? Because if you do say ordinal, you're really saying nominal by default. Okay, good question. I should have made that very clear. A collection of phone numbers. So if I got all your phone numbers right here, is that categorized? Well, it's all your phone numbers, right? It's not like I took phone numbers for most of you and then took somebody's social security number, right? See, that would be two different categories, right? This is categorized. They're all kind of the same thing. They can be put into some kind of category, right? All right, so I agree it's definitely nominal. Am I going to order them? Is there a natural order we would all agree on? Probably not, right? It's just a list of some phone numbers, okay? So I don't think that we could agree on a natural order that everyone in here would do the same thing, right? That we've been agreeing with that, so I would say this is only nominal. Now, by saying nominal, am I also saying ordinal, though? No. When I say ordinal, am I kind of, by default, saying nominal? Yeah. The further you go up, all the ones below it are also included. I'm just adding characteristics. Okay? We good? All right. Yeah, there's two more. And these are probably the two hardest ones because of what's on top there. I know I probably told you in the last few years, if you've had me for class, that 0 as a number is actually very, very young as far as the history of mathematics. Okay, it's a little baby compared to how long math has been around. And the reason it is it does sometimes cause problems, believe it or not. Okay. This is called inherent 0. Probably never heard those words before in your life. And you've probably never thought about it before. Because when you think of 0, what do you think of? Okay, a circle, all right. Somebody said nothing, right? Or none, correct? Does 0 always mean none? Okay, at the end of that, that's true. At the end of, like at the end of 1,000, it doesn't mean none, but it kind of means there's 0 ones, though. So it does mean there's no ones, right? That's what that means. Can 0 ever mean something other than none? And unfortunately, it can. And that's why it's a problem. Okay? And I'm going to tell you there's cases where 0 can mean none. And once you hear it, you're like, oh, that makes sense now. But right now, I bet you none of you can give me an instance. Yes? Number to the 0th power? Yeah, not what we're looking for, but that's a good try. Because that'd be 1, right? That's good. I like that. That's clever. That's good. Not what I'm looking for, though. I thought the females have a slight advantage on one of the examples in here. No, just all females in here would have a slight advantage, I think, on one of the examples where 0 doesn't mean none. Okay. Inherent 0. If it is inherent 0, it does actually mean none. But it doesn't always mean none. Okay? 0 is, that is. But if it's inherent 0, we are going to say that it implies that there is none. For example, there are no dogs in this room at this time. There are 0 dogs in here. Okay? There are 0 cats in here at this time. Correct? That actually means none. Has anybody come up with a time where 0 doesn't mean none? That's a funny one. Or perhaps those of you that have taken some science classes, you've seen a 0 probably lots of times. In Celsius or Fahrenheit. Does 0 mean no heat whatsoever? You see, agree that 0 is just a spot on a scale, correct? It doesn't mean none. You agree with me on that? Okay, now we have to be careful with Kelvin, all right? But Celsius and Fahrenheit, 0 is just one of the possible measurements, correct? It doesn't mean complete absence of heat, right? It's just one of the measurements. Can you go to like -20? Yeah, you can go -10. Still, that doesn't mean absence of heat. There's not much, but there's still some. It's being measured. Okay? Okay, and then there's 100 degrees. Now, you see, that's also being measured. Ladies, have you come up with my hint yet? How about dress sizes? If you have a dress size of 0, okay, does that mean that there's, you know, no waste there, in other words. No, there's still a waste, all right? It doesn't mean that there's no dress at all, right? That's not what that means, okay? And really, time is one of those tricky ones, too, okay? If you say, you know, we don't really talk about year zero, but we do have BC and AD kind of becomes a problem, right? Where you kind of throws it. Zero is just a spot on the scale, correct? You see what I mean? Same thing with the dresses, right? Zero is just a spot on the scale. It doesn't mean none, all right? So let's talk about interval. These two are very closely related. Ratio, this one down here, is the one that you've been dealing with since you started math, all right? But this one's close. Interval. These two have one very small difference, right? Again, only what you need. This will definitely be quantitative if it's in the interval. Again, we're talking about the labels, those categories you put it in, all right? It can be ordered. Oh, there's your ordinal, right? We're building on ordinal. And this time I can calculate a meaningful difference between those entries, okay? So here, 0 is just a position on the scale. It is not the inherent 0. And then I have one more thing that maybe you might want to throw in there. And it deals with this meaningful difference. Meaningful difference, but not a multiple. I think that helped last year when I told them that. And I'll explain what that means in a second. It's probably almost better for you to write down some of my examples than writing down the definition. An interval level is probably the hardest one for people to kind of wrap their heads around. What do I mean but not a multiple? Think back to the examples I gave you where 0 really didn't mean none. Dress sizes, right? Degrees Celsius. So, in other words, it's not a multiple. So is 10 degrees Celsius twice as warm as 5 degrees Celsius? That's what it would mean, what a multiple would mean, right? Is it twice as much? Is there twice as much heat there? No, that's not how that works, right? And is a dress size of 2 twice as much as the dress size of 1? Is the waist going to be twice as big? No, that's not how that works. And guys, that's how dresses are measured, by the way. I'm pretty sure, ladies, correct me if I'm wrong, but it's basically talking about the waist size, right? And so that's not how that works, right? And so they're not multiples, okay? Or again, you have to be careful with years, but is year 2000 twice that of year 1000 in a meaningful way? Does it mean twice as many years? You know, I mean, you have to be very careful. Time's a weird one. But you know what? That calculation, it's not going to be looked at as a multiple there. Okay? Again, you're looking at labels here, right? Everybody understand what I mean by that? Like if we were measuring some temperature in maybe a chemistry class of some chemical, it would go from 10 degrees to 12 degrees to 15 degrees to 20 degrees. I started at 10 degrees, ended at 20 degrees. Did it gain twice as much heat? No, it gained 10 degrees. Is that a meaningful calculation? It gained 10 degrees. There's your meaningful calculation, meaningful difference. But was it twice as much heat? No. Okay. Question? Okay. No, that's a non-inherent 0. Inherent 0 is the one where it actually means none. Like there are no cats in the room at this time. That's inherent 0. It's when you don't have it. So all we're going to do at the ratio level is add one more characteristic. And you should probably be able to tell what that characteristic is going to be. It is a ratio, or in other words, it's a multiple. Okay? So it's all this other stuff. It's interval, Plus, on top of that, it's also a multiple. Okay? So, can anybody come up with an example of that? Let's see if you can come up with an example before we start writing. What did we say? 10 degrees and 20 degrees was the numbers we used, right? Can you use the numbers 10 and 20, where 20 actually is $20 versus $10, correct? Is $20 actually twice $10? It is. That's a 2-to-1 ratio, correct? See, that's why they came up with a ratio. It's a multiple of it, correct? Is there also a measurable difference there? It's still $10. Okay? So it's still measurable. Okay? And really, that's the only difference. So do you see how it keeps building? Right? It keeps getting more. And let's face it, that is what you are used to, the ratio level. You're used to numbers being that way. Okay? If you scored a 90% on a test versus a 45% on a test, you're used to that being, that's twice as much, right? Okay, you're used to it that way, yeah.
Okay, so for like the dollar bills,
Yes.
it doesn't matter at all if you have a $20 bill, $10 bill, one bill. Like, does that matter at all?
Right, you're in the count again there. The question there was, if you have one $20 bill versus one $10 bill, you're again concerning yourself with how many of them I have. I'm concerned if I'm going to graph that, and I wanted to find out, I would start a graph like this. Here's how many $10 bills you had versus how many, wow, what is that? That's not $20 though. Versus how many $20 bills you have. You are right now concerning yourself by looking at the labels, not how many of them I had. But do you agree, this one here is twice that category there, right? I don't care how many of them I have. Not yet. We're not worried about that yet. Because remember, the title here is classifying, not counting. Okay, how do I classify it? Okay, and so again, that's why I keep saying consider the labels you would put on a graph right now on the bottom, not how many counts, because that's normally what you put on the vertical axis, right? How many of them you have. Don't worry about that right now. We're only looking at the labels or the categories you would put them in. Okay. Now, if I start putting 10 degrees Celsius and 20 degrees Celsius, yeah, don't worry about how long it was that temperature. Okay, that's still just interval. Okay, because I can calculate, yeah, that's a 10-degree difference, but it's not twice as warm. Okay, I told you today was important. Imagine trying to figure this out on your own with no book. Okay, give it a try. See what you got. We'll pause it here, and then I want to hear some explanations as to why you chose what you did. Because sometimes people make inferences on some of these, and then it changes their answer. All right? And I'm not necessarily saying their answer is wrong. All right, let's hear some answers then. Again, if you are listening to the recording, actually make sure you do pause it and actually answer them before you just get the answers on your notes. All right, number one, the body temperatures, degrees Fahrenheit, of an athlete who is exercising. Now, obviously, I told you here that it was going to be either interval or ratio, right? But maybe on your assignment, I'm just going to say, tell me which one it is. So I would seriously start with nominal and work your way up. Okay, is it nominal? Are they going to be categorized in some way? Yeah, by temperatures, right? Okay, so they're categorized. What's the next one? After nominal, you have ordinal. Would I put them probably in some normal order? You would either go highest to lowest or lowest to highest, right? So there's a natural order that we would probably put them in. We're not going to throw them in there random, right? So there is some order we would put them in. All right. Next is what? What would be the next possibility? Interval, correct? Would there be some interval between them? Because let's face it, if we were going to do that, we would probably make a graph something like this, and we would put the temperatures down here, right? And how long it was at that temperature. So in between these two temperatures, is there going to be a measurable difference? Yes. Is that measurable difference? Well, now we know there's a measurable difference, right? So we're good. So now we know that we're pretty much at interval for sure, right? Now we have to see, do I actually have ratio or not? So I have to decide, is the difference between these two also, like if it's 10 degrees versus 20 degrees, is that a multiple? And no, it's not. So we got all the way to interval, ran into a problem, okay? Because the 0 on this scale down here is not the inherent 0, right? Because once you get that inherent 0, that's when the multiples happen, all right? And so this is interval. So do you see my process for trying to figure these out? I just keep building up until I get lost. Yes? Yes. I would caution you, the question was, anytime you have temperature, it's probably going to be interval. And the answer is yes, but I would caution you, I still have to look into Kelvin. But normally I don't know too many books that are going to throw Kelvin at you in a stats class, because there is absolute zero in Kelvin. See how that's a problem? All right. So yeah, that would be a good strategy to use, is that. How about the heart rate in beats per minute of an athlete who is exercising? So on number 1, 0 was just a spot on the scale, right? So now down here, number 2, let's start again nominal. Are there going to be some kind of category we put them in? Yeah, heart rates, right? I mean, that's what they are. And then are we going to probably put some normal order to them? Yeah, probably least to greatest or greatest. Yeah, we're probably going to do that, right? If we put them on the labels down there, right? Okay, so again, here's your graph. You're going to put some labels down here. We're probably going to put them in some kind of order. Not like the M&Ms where who knows what order you're going to put them in, right? You can put them in any order you want to, right? But down here, yeah, we're going to put them in some kind of normal order. Now, interval. So this might be 80 beats per minute and then 90 beats per minute. Is that a meaningful calculation? That is 10 more beats per minute, correct? That 10 actually means something, right? Okay, so that's definitely interval. Now we have to decide, is it a ratio? So if I got all the way over here to 160 beats per minute, is that twice this 80 that we had here? It actually is, right? So in other words, 0 on this one actually means 0, that heart is not beating at all. Hopefully that never happens on your graph, all right? But it is actually none in this case, no beats per minute. You see the difference in inherent 0 and not. But that in that inherent 0 gives us those multiples though. Okay, so this is ratio. Are you clear where you should be looking for the information? Should you be looking with how big the bars are or how many of something you have? Not yet. You're looking at the categories themselves. How are we classifying this data? How are we organizing it? That's what we're talking about right now. We're not adding stuff up yet. All right? Is everybody good? Okay. There was a question, perhaps? Yeah. Okay.
Like the temperatures, how do you know that won't go up evenly? And how do you know, like, if that one, how do you know that will go like 80 to like 83 to like 95?
Oh, great question. Okay. So the question was on the difference between these two. On the temperature ones, how do I know that it's going to go up in an even number? Like maybe it would go from 10 degrees to 20 degrees to 30 degrees. Okay. Now that all depends on how you collect your data and how you graph it. What you should look at is if I had these two options, whether it's 10 and 20 or 10 and 12, does that difference of 2, is that a meaningful calculation? And that difference of 2 is, right? But let's happen I did get all the way to 20. Does that mean a multiple? Like if I did get that far, is it going to be a multiple of the first one? Is what you have to. Did I answer your question or no? Because you could put it in any order you want. Okay. I'll answer that question on Monday.